So in machine learning, basically, we use the expertise. I mean, if you remember, well, I don't remember whether you remember, but it was AA was the source of traffic really before. I mean, the drivers were phoning if there was an accident, especially out of the road. They would phone the AA to say there is a traffic here and there's something wrong in this. And then AA would report to radio, and radio gives as a news to people. That was the way it was working a long time ago. Now we have using this simple mobile to the same data, it comes to that. Another example of machine we can say is frequently asked questions. I mean, they learned that the easiest way to answer is to people is to cluster these questions to frequently asked questions, so we can answer them and put them there so everybody can learn it. But that's really some sort of intelligence in it. The main problem is in data mining. When the data is too big, too much, then to get information from it is also difficult. So Oracle was really one of the beginning people who have these softwares to be able to use a lot of data and fast enough to get some out of it. And they use these reward cards. Reward cards is a shop when you buy more, it gives you a point. But that's not only the amount of money. So it's not the total. They didn't save the total. So you spend more, they give you more points. No, what they did, they recorded all your purchases. Mm-hmm. So the shops, they give all the information to computer. So computer could say that this chap, he always buys this type of tissue, he buys this type of cigarette, and when he buys cigarette, he buys this with it, and all this sort of information. So it's the habit, the purchase habit of people. They put all of them in the database, and you can imagine how much data is there and what sort of information you can take, all sort of information, relation between purchase this and purchase that, and the duration, how often they buy this, for example, how is it related to other information on the environment, I mean, or the timing of the year, and all those sort of information. So that was the data mining they were calling it. And we see a lot of, like Amazon and others, they use these similar products. You purchase something, and it tell you that other people, not you, but other people will buy these suggestions, so suggesting the information. So the information they get is your habit and everybody's habit. And from that, they make some sort of suggestion on that. There is also suggestion, like a similar product, and also they can give you to your person what sort of thing. And weighing factor, I don't know if T is there or not, but I think there isn't, because it's the same idea as weigh. But I think we call it weighing factor, without T. I believe it's without T, yes. This is, even I forgot now what was it for, but basically it's evaluation of the sort of effect of everything. What is importance, yes, of everything. One of the things which they used, for example, before we really machine learning as such, but machine learning as in practice they were using, this is since 50s really, 1950s, is to use the personality trait. And these big five, after many years it came. It wasn't like this, I mean, obvious five, but especially this is the use of it is for jobs. So they can divide people on different type of personality on 5 issues, and each issue is subdivided to 6 parts. Openness, how open they are to other people, consciousness, how they are to the job and they want to do it exactly or they don't care. Extraversion is how much you like to talk to people or do you want to be to yourself. Agreeableness, okay, tolerant, how tolerant you are, and how asabi, neuroticism, how you become angry or not. Anxious to become so easy or not. So they decided people act differently according to this type of people, and by the questionnaires they could send you from a questionnaire you can understand what is your personality, or later on, no, from the photos, for example, now even Microsoft, it's a Windows, sorry, yes, it's Windows, yes, I think it's Microsoft. They put these background photos, and they say if you like it, you just say like it. We will give you better similar photos. But they want to test you to see what sort of things you are. One of the way also to show is like this: they give you different photos, and you just say I like this, I like that. But in fact, they have put all these features in that photos. I mean, they have selected the photos according to these features, so they know. When you select, you have one of these, or you have more of this or less of that. In fact, ourselves, even we did some work after that. I don't know, about 7 years ago, 6 years ago, long time ago. In Iran, we wanted to see the clothing, what sort of people like, what sort of clothing they like. So we employed psychologists, and they say, for example, what you see, you divide it in different aspects. One is the symmetry, one is the color, one is the how busy is it, or how calm is it, or less features, more features. So they put a lot of these in the photos, so we could give photos, not even dress, photos, normal, other scenes. I mean, we give it to people, and they like this scene or they don't like that scene, and afterward we could know that what sort of dress they would like. So that sort of idea comes part of the machine learning, which means they all these features, if how high it is, how low in that feature, and when they have different features, so they have different personality, and from that they could tell you people who bought because they had this personality or because that personality. That goes part of the data mining, and altogether the machine learning as a whole, they have these 80 stages. Well, we can make it less or no, but these are the main stages of machine learning: collecting data, then labeling data, categorizing it, and so we put them differently. Visualize data on what else, what you have on the shape of it, because most of data is visualization. Really, a lot of data comes from visual data, but not necessarily always visual. Identify features, so how we can separate them, and then we train the model on this is that and that's that, for example, and evaluate models to see if the models which you are training, is it good or not. I mean, the features you have defined, these features are right features or not right features, and deploy it in practically, test it really, and monitor at the end if you are doing it good or not. And the process continues, improves. Always we improve the definition, and depends on the feedback we get from the market. Deep learning is a different one. So machine learning, so we had expert learning, expert systems. Expert systems, we had to have very good, experienced people to give us the information. That's for sure. Next comes this machine learning. Machine learning was somehow expert. I mean, it can give you personality, this possibility, some sort of percentage. When we go to deep learning, you're dumb. you are really dumb. I mean, we want, for example, teach the birds or the language, the little. That's one of the projects we can always do. Any animal, you want to talk to this animal or to learn. You don't know anything about that animal or the talking of it. But if you use deep learning, you can teach yourself or the computer to do it. Because this system is in our mind. That's the way our mind works. In fact, our brain, not mind, brain works like that. It has these neurons, which has a lot of input and a few output, and each output goes to another neuron cell system.
What is the definition of deep learning?
Definition of deep learning? Definition is neural network, they call it. It's based on connection, or they can call it connectionism. Connectionist, yeah, connectionist.
Connectionist of what?
Connectionist is connecting all information connected to each other. That's connecting, that's it. We use the weighing factor and summation, simple. Very simple summation. But simple does not necessarily mean work. Because I tried this, it's really difficult. So it's coefficients. If we have a number, here we have 5 digit, which is 1 to 31. We can write it in digital, in binary form. And we can put a coefficient, a multiplication of that number 0 or 1 to that coefficient, and we sum it. And at the output, we can just truncate. Say if it's more than 5, becomes 1, less than 5 becomes 0. That's the rule normally they do it. So if you can find these coefficients in a way that it can understand if this number is divisible by 3 or not, multiple of 3 or not. If it's a multiple of 3, it becomes 1. If it's not, it becomes 0. For example, if you try to calculate that. I did a program for it, and I was, almost couldn't reach it. Because it's so simple. There is no hidden layers inside. We may put layers inside, and that becomes it. But basically, that's the way it does. I mean, simple work like that. If you try yourself to do it, so you can understand that it's not as easy as they are doing it. It's easy to say, but it's not easy really to do. It's really difficult. So not everywhere works, and not everywhere is easily done. But anyhow, that's I believe because we have to stop here, because yes, we go to another subject, which is IoT, with totally almost different subject. Inshallah, okay, we'll discuss that later on another time. Okay.